It's worth to hear today. Time teaches everything. It will all be fine if you follow these videos one after the other from the playlist. It's one step away, one click away. All the solutions will pop up in your mind if you pay time and attention towards this video today. The topic today is on tests of hypothesis, large samples from statistics. So here are the few steps here. See the first four important tests to test of significance here is testing of significance for the single proportion, difference of proportions, single mean and difference of means. So the third topic here, the testing of significance for single mean. I have uploaded two problems related to this series and here are the few problems which I'm going to teach you. First one is the testing of significance of a single mean large samples. When n value is greater than 30, we say it is a large sample. The working rule for this is very simple here. The first one is null hypothesis, alternate hypothesis, level of significance, test statistics and conclusion. Null hypothesis means if x bar is equal to mu, there is no significance difference between the sample mean and the population mean is the null hypothesis. Alternate hypothesis means the alternate statement, that is there is a significance difference between sample mean and the population mean. And the next one is level of significance. So this level of significance we have to take from the problem, whether it is 1% or 99%, 95%, 5%. So we have to select from the problem. If it is not mentioned, please take 5% level of significance. And the next one is test statistics. We have to apply in the formula. So what is the formula here? So here x bar, mu, sigma and n are given. So we have to use this formula, that is z is equal to x bar minus mu by sigma by root n. So in this we have to substitute and we have to calculate. The calculated value you have to remember, and from the table level of significance z alpha by 2 will be there. So we have to compare both the values. If z is less than z alpha by 2, we have to accept h naught, and if z is greater than z alpha by 2, we have to reject this h naught. So this is the working rule. Already I have solved 1-2 questions and this will be the third question here. So the third example here is an oceanographer wants to check whether the depth of the ocean in a certain region is 57.4 fathoms as had previously been recorded. What can he conclude at 0.05 level of significance if the reading taken at 40 random locations in the given region yielded a mean of 59.1 fathoms with the standard deviation 5.2 fathoms? See here, whenever you read a problem, you have to underline all the numerals here which I have done. So from the numerals, so you don't miss anything if you underline while reading itself. See here, the first one is the depth of the ocean in a certain region is 57.4 here, and the next one here is 59.1 fathoms. So here both are there, and the next one is 40 random locations. N is given as 40 and standard deviation is given as 5.2 here, and the next one level of significance is given as 5% level of significance, and the next one here among these two both are means here. So first we have to decide whether which is mu and which is x bar and mu. So here I'll tell you one logic: whichever it is a bigger one you take as x bar, and whichever it is a smaller one of means you take it as a mu. So x bar is equal to, this is 59.1 and mu is equal to 57.4. So this is a small logic. Please remember, then you don't get a wrong answer. First one is null hypothesis. Mu is equal to 57.4. Alternate hypothesis, mu not equal to 57.4. We have to take an alternate statement. Level of significance here, it is already given as 0.05 level of significance. And test statistics. So here x bar is given, mu is given, sigma is given, n is given. So x bar minus mu by sigma by root n. What is x bar here? 59.1 minus what is mu? 57.4 by what is sigma? 5.2 by root 40. The value here is 2.067. So here From 5% level of significance, please remember the value here is 1.96. So we have to compare both the values. This is calculated value and this is the tabular value. So the calculated value Z is greater than the tabular value. Therefore, we have to reject H naught. So we have to reject H naught. That is mu is equal to 57.4 is not true. Therefore, so this statement is not true. Therefore, mu not equal to 57.4 we have to accept. The next question here is, the fourth question is also very simple. In a random sample of 60 workers, how many workers are there? So whenever you find a numeral, please underline there are 60 workers. N is equal to 60. The average time taken by them to get to work is, so here average time is given as 33.8 minutes with the standard deviation 6.1 minutes. Can you reject? See here, what is it? It is asked, can you reject the null hypothesis? Mu is equal to, that is 32.6, in the favor of an alternate hypothesis, that is mu greater than 32.6 at 0.025 level of significance. So what is given and what is to be found? See here, n value is given as 60, standard deviation sigma is given as 6.1, and here among these two, 32.6 and 33.6, there is a logic that x bar will be the greater value, that is x bar is equal to 33.8 and mu is equal to 32.6. So if x bar, mu, sigma, n are given, so we have to find that it is a single mean. Null hypothesis, the first thing here is the null hypothesis. Mu is equal to 32.6. Alternate hypothesis, mu is greater than, see here, mu is greater than 32.6. Level of significance, that is 0.025. So from the question it is 0.025. Test statistics, and this is the formula here, that is Z is equal to x bar minus mu by sigma by root n. X bar clear, that is 33.8, mu that is 32.6, sigma 6.1 by root 60. So if you calculate, this is 1.5238. See here, when you compare with this 0.05 level of significance, this is the tabular value is 2.58 and calculated value is 1.5. So this is obviously less than the table value. Therefore, Z is less than the table value. Therefore, we have to accept. H naught should be accepted. What is should be accepted? Mu is equal to 32.6 should be accepted. So this is how, these are the 5 steps. This is the conclusion part, and this is also very simple. Next one is the fifth question here. A sample of 900 members. See, very clear, 900 members. So 900, it is a numeral I am underlining, has a mean of 3.4 and standard deviation is 2.61 centimeters. Is this sample, so this is the question, is this sample has been taken from the large population of mean 3.25 with standard deviation again, that is 2.61 centimeters. If the population is normal and its mean is unknown, find 95% fiducial limits of the true mean. So here we have to find the confidence limits. For finding the confidence limits, what are given here? N is equal to, clear, it is very clear that n value is equal to 900. So n is equal to 900 is given, clear. And the next one, mean value here. So mean is 3.4 here and next one is 3.25. Which is bigger one? 3.4. So bigger one we have to take as x bar is equal to 3.4 and mean mu is equal to 3.25 and sigma value is equal to 2.61 and s is also 2.61. So all the values are given here. So we have to find the confidence limits also. The first thing is, the first one is null hypothesis. So from the null hypothesis, what is the statement which we have to take? Assume that the sample has been drawn from the population mean mu is equal to 3.25 and the alternate hypothesis here is mu not equal to 3.25, and here is the formula here, Z is equal to, see here, test statistics, Z is equal to x bar minus mu by sigma by root n. What is x bar? X bar is nothing but 3.4 minus 3.25 by sigma 2.61 by root 900, which is equal to 1.724. So here, as it is 5% level of significance, Z alpha by 2 value will be 1.96. See here, Z alpha by 2 value is equal to 1.96 from the table here. And therefore, 1.96, 1.7, which is smaller one. So Z is less than Z alpha. So Z value is less than Z alpha. Therefore, if Z value is less than Z alpha, then we have to accept null hypothesis. That is, what is null hypothesis? Mu is equal to 3.25 should be accepted. And next one is fiducial points, that is confidence limits. So here the confidence limits are nothing but x minus, this is z alpha by 2 into sigma by root n, comma, that is x plus this is z alpha by 2 by sigma by root n. So these are the limits. So in this limits, what is x bar here? This is 3.4 minus 1.96 into sigma is 2.61 by root 900. So one time we have to subtract, one time we have to make an addition. So this is 3.4 plus or minus, this value is nothing but 0.1705. So if you subtract, the value here is 3.57. If you make an addition among these two, this will be 3.2295. So this is how we have to find the confidence limits. So these are the formulae which you have to keep it in mind. And the next one is a sample of 400 items. See, the sixth question here is a sample of 400 items is taken from a population. So whenever you find a numeral, please, a sample means n of 409 items is taken from a population whose standard deviation here is 10. Standard deviation is 10 and the mean of the sample is 40. Test whether the sample has come. So this is the question. Test whether the population has come from the mean, that is 38, and we have to calculate 95% confidence intervals for the population. Intervals here, what is given? N is given is equal to 400. So there are two means here, 40 as well as 38. So whichever it is bigger, you have to take x bar. So x bar is equal to 40, mu is equal to 38, and sigma, the standard deviation, is equal to 10. And see here, it's very easy, that is null hypothesis. Mu is equal to 38. So test whether the sample has come from the population with mean 38. Mu is equal to 38 we have to take. In the alternate hypothesis, mu not equal to 38, level of significance, that is 95%, which means 0.05. And test statistics, and this is the formula, z is equal to x bar minus mu by sigma by root n. Don't forget here with this formula here, x bar, this is 40 minus 38 by sigma 10 by root 400, the value here is 4. Z value is equal to 4. Z we got as 4. At 0.05 level of significance, Z alpha by 2 is equal to 1.96. Clearly, the calculated value is greater than the tabular value. Therefore, Z is greater than Z alpha by 2. If Z is greater than Z alpha by 2, please reject. We reject the null hypothesis H naught. So, what is H naught? Mu is equal to 38. It is rejected. The sample is not from, see here, this is the conclusion part. The sample is not from the population whose mean is 38. And the next one, what is it? It is asked to find out 95% confidence intervals. So the interval is also very clear. X bar minus Z alpha by 2 into sigma by root n, comma, X bar plus Z alpha by 2 into sigma by root n. What is X bar here? So X bar is very clear as 40 minus Z alpha by 2, 1.96, sigma value is equal to 10. See here, sigma value is equal to 10, and root n, that is root 400, and mu is equal to 38. So every value is very clear. So one time we have to subtract and one time we have to make an addition. Please use your calci. If you use your calci, if you subtract, this will be 39.02, and if you make an addition, this is the formula. And this is how we have to solve, and there are two more questions. So let me explain you. An ambulance services claims that it takes an average less than 10, see here, less than 10 minutes to reach its destination in emergency calls. A sample of, see again, a sample of 36 calls has a mean of 11 minutes, and the variance is 16 minutes. Yes. Test the claim at 0.05 level of significance. See here, all the values are very easily given here. N value, the sample means n is equal to 36 is given. So mean here is 11, and the average here is 10. Among these two, which is bigger? X bar is given 11. 11 is equal to x bar and mu is equal to 10 bar, and variance is given at this time. So variance is equal to 16. Therefore standard deviation is equal to root over variance, that is root over 16, which is equal to 4. Sigma we got value as 4. And now null hypothesis, mu is equal to 10. Alternate hypothesis, mu less than 10. Level of significance 0.05 level of significance. And this is the test statistics. Here is the formula: z is equal to x bar minus mu by sigma by root n. What is x bar here? 11 minus 10 by 4 by root 36. And therefore the value here is 1.5. At 5% level of significance, see here, at 5% level of significance, the value is 1.645. So when you compare this one, calculated value is less than the tabular value, and therefore conclusion, we accept the null hypothesis H naught. And this is how we have to do. And the next question here is, so this is also so important. It is claimed that the random sample, again the sample 49 tires, has a mean life of 15,200 kilometers. This sample was drawn from the population whose mean is 15,150 kilometers and a standard deviation is 1200 kilometers. Test the significance at 0.05 level. See here, these are all given here. N is equal to 49. So n value is equal to 49 and x bar. See here, there are two means here. Mean life, that is 15,200, and next one is 15,150. So among these two, which is greater? This one is greater. So name it as x bar. X bar is equal to 15,200, and here mu is equal to 15,150, and sigma, the standard deviation, is equal to 1200, and the level of significance is 0.05. And as usual, this is null hypothesis. So for null hypothesis, mu is equal to 15,150. Alternate hypothesis, mu not equal to 15,150. Level of significance 0.05. And the critical region here, z lies in between plus or minus 1.96. And test statistics. And this is the formula: x bar minus mu by sigma by root n. So x bar is ready as 15,200. Mu is ready as 15,150 by sigma value is 1200 by root 49. The value here is 0.2917. So here, if you compare this one, this is the tabular value and this is the calculated value. Clearly the calculated value is less than 1.96. Therefore, see here, we accept the null hypothesis. So we accept the null hypothesis. So what is null hypothesis? Mu is equal to 15,150 kilometers is true. So this is how we have to calculate if mu, x bar, sigma, n are given. So we have to use the formula, that is z is equal to x bar minus mu by sigma by root n, and all the 5 statements which are very clearly mentioned in the textbook. And definitely hope you got an clarity on what to do, how to do, and how to solve. And definitely you can score more if you follow these videos. If you really like this video, please pass it on to as many friends as you can. That is the greatest help needed. And thank you for staying till the end. Go to the playlist and prepare well. Thank you so much.